Hello everyone, welcome to the course Math 110. It's differential calculus and coordinate geometry. In this course, we'll learn about limits, continuity, differentiation, applications of differentiation, and in the coordinate geometry part, we'll look into different coordinate system and conic sections. In this video, we'll cover preliminary topics that we need to understand for the course. These are the things you did in high school, and I'm pretty sure you're really familiar with it. So let's get started. Preliminaries. The first thing we need to know is functions. So what are functions? Functions are like machines that gives output based on the input you give. For example, if you give a certain input, it gives you an output based on the input you give. Let's see. It's like function of x. This is an example. This x is the input you give, and the output you get is the function. The input, we call the input as the domain of the function, domain, and the output is basically the range. Inputs are basically numbers. Think of them as numbers. Any number you can imagine. It's the input you give. And the output is the value you get. So we call this domain and the output part range. So for example, if we input the value 2 in the function, in this function, we get output of 3. So anything you give input, it just adds 1 to that input value. This is a numerical example of a function. We can represent functions graphically as well. Let's see an example. I assume everybody is familiar with this coordinate system. It's Cartesian coordinate system. Cartesian. We'll learn more about this in the later part of the course. It's the x-axis and the y-axis. For example, you gave an input of 2 in the function. So if you give an input of 2, we get an output of 3. This is the graphical representation of function. It can be y, or you can represent it like f of x. It's the same thing. Y is the value you get after plugging in the function, the value of the function. 2, for example, for 2 you got 3. Another thing we need to know is something called interval. So what is an interval? Interval is the part of the x-axis that you are considering. What does that mean? For example, here, let's say you are considering 1 to 4. Say you are considering 1 to 4. This is your interval, the part you are considering. Let's say this is the part you are considering. This is our interval. Why do we need interval? We need interval to study the behavior of functions. Let's see an example. Let's see our initial example. F of x equals x plus 1. X plus 1. So for the value 1, we get an output of, for the value 1, we get an output of 2. For the value 3, we get an output of 4. For the value 4, we get an output of 5. So let's say, so here, this is the behavior of our function in that interval. That's why we need the concept of interval, to study the behavior of the function in that particular area. So we understood the concept of functions, how to graphically represent them. Let's say this is the graphically, and we understood what an interval is. Now we can move on to the concept of Cartesian continuous functions. Let's say continuous functions. So what are continuous functions? We'll learn more about continuous function in the later videos, but for now we just need an intuitive idea about continuous and, let's say, both of them, the continuous functions and discontinuous functions. Continuous and discontinuous function. Let's say this is our graph. So what are continuous functions? From this you get the idea that continuous functions, from the name you can guess, continuous functions are functions that you can draw that doesn't have any discontinuity. And what does that mean? Let's say this is the interval you're considering. In this region, in this interval, does our function have any value that we don't know? No. You have every value. Whatever value you pick in this interval, it might be 1.5, f of 1.5, or anything you want. In the interval, the function has every value. And what about discontinuous functions? Discontinuous functions are, for example, we don't have a certain value in the interval. Say this is our interval. Maybe say for f of 2.5, let's say f of this is 2.5. Let's say our function f of 2.5, we don't have a value of that function. The function, there is no value for f of 2.5. We say there is a discontinuity, and this is a discontinuous function. We'll know more about this in the later part of the course. The last thing I want to introduce is something called indeterminate forms. There are certain values of the function. There are certain values that aren't defined in mathematics. That is, we don't know what they are. These are called indeterminate forms. For example, 0 over 0, infinity over infinity. These are the things we don't, and there are some other, but we mainly need these two. So indeterminate forms are things that we don't know what they are. They are the things that we don't know what they are. For example, you can't divide 0 by 0. We don't know what that is. This is an indeterminate form. We'll learn more about indeterminate forms when we study limits. So this is the basic idea of the preliminary stuff you need to know. We learned about functions and represented them graphically. We learned what an interval is, a continuous function, where the function has value, every value, we have every value of that function in the interval we are considering. We then studied discontinuous function. There are certain values that we might not have. These are our discontinuous functions, and indeterminate forms. And the things that we don't know what they are. They aren't defined in mathematics.